Hi everyone, welcome to Job Fever. We are going to continue our lead code 75 code challenge. So now we are going to cover this question. Okay, we will do the coding for this given question, which is can place flowers. So this is the question. Question number 4 we are going to cover today. So I have already opened this. So I will show you. So this is 605 number which is given by lead code. So can place flowers. So we'll try to understand the question and then we'll try to understand the approach and then we'll do the coding. So let's get started. So this is our question. You have a long flower bed in which some of the plots are planted and some are not. However, flowers can't be planted in adjacent plots. Okay, given an integer array flower bed containing 0 and 1, where 0 means empty and 1 means not empty, and an integer n return true if n new flowers can be planted in the flower bed without violating the no adjacent flowers rules and false. Okay, so this is our input, which is flower bed, and n is equal to 1. Okay, so if it is 1, that means the flower is already planted here. Okay, and if 0, the flower is not planted, 0 flower is not planted, and 1, that means a planted. So we are n is equal to 1, that means the this is the plant number of plant, so it should be planted in this flower bed. So there is some condition to plant the flower. So what is the condition? So condition is the before and after. Okay, so before and after there is uh, so plants should not be planted before and after. Okay, so if you see the index number second. Okay, so here 0 is there, that means that there is no plant. Okay, and if you see that this index 0, so there is a 0 here. Okay, so there is no plant here. Okay, and 0 here also, so there is no plant here also. So if you can plant here, you can make it 1. Okay, you can plant the plant here and you can make it 1, because there is no any plant before this, and there is no any plant before, there is no any plant before and after this. Okay, so you can plant your flower here. Okay, at this place, and then if it is planted, then you can return true. Okay, and in this scenario, if it is not, if it is not planted, then you have to return false. In this scenario we have to plant. Okay, and this is the flower bed. Okay, so where can you plant your to plant? It is possible. So here you can plant first plant, but you can't plant second flower. Okay, there is no space to plant second flower. Okay, because there is some condition to plant the flower, which is flower can't be planted in adjacent plot. Okay, see, if it is already planted, so you can't plant after that plot. Okay, so if one is already plant flower is already planted here, so you can't plant the flower after one. Okay, because already planted. Okay, so where you can plant, so it should be before and after, it should be vacant. Okay, then you can plant only. So this is our condition. So we have to think the approach, and then we have to pass these two test cases. Okay, so firstly what we can do, so we'll try to calculate the length of this flower bed. Okay, so int flower bed, int length is equal to flower bed dot length. Okay, so we have length of this of flower bed. Okay, and we can make it count. Okay, count equal to 0. Why you are going to make count equal to 0? If because we did not we did not planted any flower till now, so we have made count equal to, if you plant, then we'll make it count plus 1. Okay, so we are going to think approach. How can we do? So firstly we are going to take one loop from 0 to n, 0 to length minus 1. Okay, for int I equal to 0, I less than length minus 1, and then I plus plus. So I have to take this, we have to take this one loop from I is equal to 0 to I length minus 1. Okay, and then we have to, so this is the number of plant we wanted to plant. So if it is, see here, count, we haven't planted any uh, plant, or we haven't planted any flower till now. So count is 0, and we want to plant n number of flowers. So this should be, this condition, this should be true till count less than n. Okay, so if count less than n, then it should run. Okay, so you can make this end condition. Okay, because it may possible, that means the count may increase. Okay, count may increase beyond your number of plant. Okay, so in this area we are making one condition here, so it should not be, y- your flower should not be planted more than your given flower. Okay, and now we are going to check the condition. Okay, so if you take this one, this example, which is I is equal to 0. Okay, so how can we think? See, if there is no if there is no plot before this one. Okay, and there is no, so this is already one. So let's think for this. Okay, so there is no plot before this index. Okay, and after this index there is no any plot. Okay, so there is no any flower planted on this plot. So firstly we are going to think, how can we make left empty and then right empty. So make it left empty. Okay, left empty, that means the, if, so this is the if this is I is equal to 0. Okay, if I equal to 0, okay, then left will be always empty. Okay, because there is no element before this. Okay, so always left will be empty. Okay, and when right will be empty, so if this is the last element, when it is last element, then it always right will be empty. Okay, so we are going to take two condition, and I will try to make you understand. Boolean equal to left empty, we are going to think in which condition left will be empty. Okay, so left empty equal to I equal to 0. Okay, that means I equal to 0, that means it will left will be empty, means any there is no any plot available before I is equal to 0. Okay, then left will be empty. Okay, and then in which scenario left will be empty, there is another case, which is I minus 1 equal to 0. Okay, let's imagine we are on this index. Okay, so if I, this now I equal to 2. Okay, so we are on this position. So if I minus 1, okay, equal to 0, that means the left is also empty. Okay, so there is another condition, which will be flower bed I minus 1, okay, if equal to 0, okay, then in this scenario also our left will be 0, okay, left will be 0, left plot will be 0, okay, because there is no plot planted in, there is no any flower planted in this plot, okay. So if I minus 1 equal to 0, I, this is the our I equal to 0 in this in our case, okay. So if I minus 0 equal to 0, that means left is empty, okay. So this will be, in this case left will be empty, and we have another case in this scenario also left will be empty if this is the first element. If it is first element, then anyhow the left will be empty, okay. So we can think about the right, okay. If left is also empty, right is also empty, then we can plant here, okay. But because but there is one here, that means a flower is already planted here, okay. But if think if there is no any flower planted here, okay, then in this scenario, if this is 0, okay, that means that there is no element after first, okay, and before also it is 0, that means that we can plant here one flower, okay. So in which scenario we can plant our flower. So this is the first scenario we can plant, okay, but it should be in end condition, okay, because left also should be empty and right should be also empty, okay. So left should be empty in case of both the scenario. And now we are going to think how right will be empty, right empty, okay. So how right will be empty. So if this is the last condition, okay, length minus 1. So if I equal to length minus 1, okay, if I is equal to length minus 1, this is the index, then this is the in this scenario, right will be also empty, right plot will be, because this is the last plot, okay. So in this scenario there is no any plot after this last plot, okay. So in this scenario also right will be empty, and then now one another scenario will be there, in which scenario right will be empty, okay. So which is I plus 1, flower where I plus 1, okay. So this is our current, and if you'll do I plus 1, so if it is 0, then in this scenario also right is empty, okay. So if both the scenario is, so this is the second condition. So if first and second condition will be true, then our, then we can uh, plant the flower in at index, okay. So see, can we plant at ith place, okay. So we are going to check, so we are going to check, can we plant the flower at first ith place, okay. So for that purpose ith place should be 0, okay. For this is the condition, ith place should be 0. If ith place is equal to 0, equal to 0, then we can plant. But left and right should be also empty, okay. So current is also empty, and left and right should be also empty, then we can think to plant, okay. So this condition we can make inside this if condition, okay. So now we have current is empty, current is empty, sorry, current is empty. And now we have written condition to check how first will be empty and second will be empty, okay. So then how can we plant the flower, okay, if current is empty and right and left both are empty together, okay. Then we can, it should be in end condition, then we can plant plant the flower, okay. So left and left and right. Okay, if both are empty, then we can plant plant the flower. So how can we plant the flower? So we can make this current condition, we can current index we can make it 1. Okay, so if it is 1, that means the flower is planted, because 1 is denoting the flower is already planted here. Okay, so we have made, and then if planted, then we can make it count plus plus. Okay, so like this we can write the logic, then we will try to return true and false. Okay, if given number is already the given number is planted. Okay, a given flower is planted, then you can, this is the given flower. Okay, so if it is planted, then it should return true. So if count equal to given number, that means the all flowers, all flowers have been planted. Okay, so we can return here, this is our if, outside if. So we can return count equal to n. Okay, so if it is planted, so it will return true. True if planted, or false if not planted all. Okay, not planted or flowers. Okay, and this condition is to check left and right empty. Okay, so let's run and check, are we able to pass all test cases or not. Yeah, we are getting some compile time error. Okay, so here it's asking for semicolon. Let's run again. RTURN return. Let's run again. Yeah, test case 1 is passing and test case 2 is failing. Let's check, there is some problem. K test case 1. So in test case 1, flower berry n equal to 2 and output is true, but getting here false. So let's check once why we are getting. So here I less than eh, I less than length should be there. Okay, it should not be length minus 1. Okay, because in this case 1 2 3 4 5, length will be 4. Okay, so index should be less than, index should be 4, so which is length minus 1. So let's run and check again. Again it's failing. The second condition, let's check why it is failing. Forward bed I minus 1 equal to 0, right empty I equal to length minus 1, and flower bed, this is our condition, I plus 1 equal to 0. Then left right should be, if right empty, sorry, we are okay, so we have made two times right. Okay, so here left empty and right empty should be there. Okay, so both should be true. So let's run again. Yeah, all test cases are passing here. Okay, so this is the flower bed and this is the n plant number of plant you want to plant, and this output should be false because it will plant only one plant here. Okay, so it should false, so getting false here. In case of case 2, in this case 1, n equal to 1, so it should be true because we will be able to plant one tree here. Okay, expected true, and output we are also getting true. So this is a, so like this we can do. So this is one of the approach to handle this, to write the code for this question. Okay, so there are various approach, so you can do your code in another approach. If you have any other approach, so you can also let me know in comment section, so we can also try to understand the code. So if there is any doubt, so please let me know in comment section. We'll try to understand, we'll try to solve. So thanks for watching. If you're loving my effort, please like, share and subscribe. Bye everyone.